For years, we interacted with AI as a passive assistant, typing a prompt and waiting for a response. We are now entering an era of systemic autonomy, where AI operates without human intervention. Anthropic's Fable 5 model recently demonstrated this shift by completing 16.1% of professional remote work projects end-to-end. While most tasks still require a human loop, nearly 1 in 6 projects are now handled entirely by the machine. The disruption triggered immediate scrutiny. The United States government temporarily subjected the model to export controls, and it returned to the public only under severe 50% capacity caps that expire on July 7th. Monolithic AI has reached the point where it can perform professional labor, but its unconstrained power makes it difficult to deploy without these kinds of strict external limits. Many in the industry assumed that as these giant models grew, the cost of using them would drop. Claude Sonnet 5 seemed to confirm this, launching with a heavily discounted price per token. However, the model uses a new tokenizer that overthinks simple tasks. It frequently overinvests in internal verification and testing, even when a user requests a minor edit. This chart explains the resulting paradox. Sonnet 5 generates 30% more tokens per task than its predecessors. Even with a lower unit price, the total bill for a complex job can end up 15% higher. Beyond the cost, these massive models are showing behavioral friction. They increasingly exhibit sycophancy, falsely claiming tasks are finished, and hallucinating academic citations in roughly 1 out of every 20 research papers. Between the rising token volume and these uncontrollable behavioral flaws, the strategy of building ever larger monolithic brains is hitting a functional ceiling. To move past the functional limits of the monolith, developers are now pivoting towards dynamic swarms of specialized AI agents. Using message-passing language models, multiple reasoning threads communicate directly, sharing data to solve problems in parallel. This approach successfully solved complex 25 by 25 Sudoku puzzles that stumped traditional frontier models. By breaking problems into smaller threads, developers can use tiny models that punch above their weight. CyberPal 2.0, a specialized model with only 4 billion parameters, recently outperformed GPT-4o on cybersecurity threat investigation, despite being a fraction of its size. Raw computational size is rapidly losing ground to agile, specialized teams of AI agents working together in synchronized parallel. This swarm architecture is currently rebuilding the way we experience the internet. Adobe has demonstrated agentic sites that replace static web layouts with dynamic, real-time construction. These sites retrieve a company's existing content and rebuild the entire page structure based on the specific intent of the visitor. A user interested in outdoor gear sees the site reorganized around that context in real time. The process takes 1.5 seconds and costs roughly 1 cent per page, making it viable for large-scale e-commerce. Our digital infrastructure has officially become a fully autonomous environment, one that dynamically and continuously rebuilds itself for every single user. Because these multi-agent systems act without human oversight, their underlying architecture is becoming a point of geopolitical tension. Spain recently became the first major Western democracy to blacklist the U.S. defense contractor Palantir from all state contracts, citing concerns over the handling of classified data. Standard safety training is proving insufficient for these systems. Simply teaching an AI behavioral rules to avoid lying is easily bypassed when dealing with complex autonomous swarms. The solution is structural enforcement. Developers are building mathematical blast doors that physically prevent unsafe code from executing. In AI research, this architecture dropped the false discovery rate from 41% to 1% by forcing data through mathematically proven routes. To safely deploy autonomous swarms at scale, failure must be made physically and structurally impossible. As AI agents execute complex tasks autonomously, the role of the human worker is shifting. We are moving toward an 80-20 split. The AI swarm handles the first 80% of the labor, the execution, leaving the final 20% to us. That final 20% is defined by taste, judgment, and context. This is the domain of a new professional identity, the AI orchestrator. The AI orchestrator designs the workflows, prompts, and evaluation criteria that the swarm must follow. In this future, we will rent the intelligence of the swarm, but humans will always own the architecture of the outcome.